These are the solutions to Unit 1 Practice Exam A. So what we do here for Part A, remember, and it's a misspelling, I apologize, coterminal angle is one full revolution of a circle. So if we have a 100-degree angle and we revolve 360 degrees around that angle, we're going to end up with 460 is one positive coterminal angle. If we have our original angle and go the other direction, subtract 360 degrees, we will end up with our negative coterminal angle. That's negative 260 degrees. If we want to convert 100 degrees into radians, remember the conversion factor, if we're trying to cancel out degrees and go into radians, the unit of measure that's being canceled goes on the bottom. So 180 degrees is on the bottom of the fraction, the denominator. We're going into radians, so pi radians is in the numerator. You multiply, we get 100 pi divided by 180. If that is simplified, we have 5 pi over 9 radians. Question 2, if we have angle theta 30 degrees inside of a right triangle, so I'm just going to draw a random right triangle, 30 degrees. The side adjacent to theta is 58. How long is the hypotenuse? So we need to use one of the 6 trigonometric functions based on the situation we have here. Angle 30, we have the adjacent side, and we're trying to find the hypotenuse. So if we have adjacent and hypotenuse, we can use cosine. So if we use cosine 30 is equal to the adjacent length divided by hypotenuse, now we can solve this equation for x, which is the length of the hypotenuse. So I'm going to multiply both sides by x. And then divide both sides by cosine 30. And now we have cosine 30. Remember, 30 is one of those special angles, 30, 45, or 60 degrees. So we can evaluate cosine of 30 using the unit circle. So if we're going to use the unit circle, remember 30 degrees is pi over 6, and cosine on the unit circle is the x value at that point. So the x value at pi over 6 or 30 degrees is the square root of 3 over 2. So we change cosine of 30 into the square root of 3 divided by 2. If we continue to simplify there, 58 multiplied by 2 is 116 divided by the square root of 3. So that's the length of the hypotenuse. So for question 3, we have a right triangle. If this angle is 60, we know this one's 30. And if you recall, the sum of all 3 angles of a right triangle is 100, or of any triangle really, is 180 degrees. So we have 90 degrees plus 60 degrees, that's 150 degrees, which leaves theta as 30 degrees. So we know theta is 30 degrees. Now I'm going to solve for A first. If I'm going to use 60 degrees, then in reference to 60 degrees, I know the opposite side, and I'm trying to find the adjacent. So if I know the opposite side and I want to find the adjacent, opposite and adjacent could be a tangent function. So to find A, I could use the tangent function of 60 degrees is equal to the opposite length divided by the adjacent length, so 9 divided by A. If I multiply by A on both sides, and then divide by tangent 60, So a is equal to 9 divided by tangent 60. And again, tangent is, or 60 degrees is one of these special angles that we can find on the unit circle. And the definition of tangent is y divided by x. So at 60 degrees, on the unit circle, we have a y value of square root of 3 over 2 and an x value of 1/2. So root 3 over 2 divided by 1/2 is just root 3. So this is equal to 9 divided by the square root of 3. This is 9 divided by root 3. Now, if we want to find c, there's a couple ways we could do that. Now that we have two sides of the right triangle, we could just use Pythagorean theorem, a squared plus b squared equals c squared. Or we could use another trigonometric function. Um, for example, if I want to use 60 degrees again and use the opposite length and not trying to find the length of the hypotenuse, opposite over hypotenuse could be a sine function. We could say that sine 60 is equal to the opposite length divided by the length of the hypotenuse. So if we multiply both sides by c and then divide by sine 60, we're going to have c is equal to 9 divided by sine 60. And the definition of sine on the unit circle is the y value. So at 60 degrees, the y value is root 3 over 2. So this could be 9 divided by root 3 over 2, which is 18 divided by the square root of 3. So we have theta is 30 degrees, a is 9 divided by root 3, and c is 18 divided by root 3. Question 4, we have some tower here, and there is a guy wire 1,000 feet long. It's going to make a 43-degree angle. The ground, how tall is the tower? So this guy wire is 1,000 feet long. Here's the ground. Question is, well, one of the questions is how tall is the tower? The other question is how far from the base does the base of the tower does the wire hit the ground? So let's solve for x first. If we're going to use 43 degrees and we're going to reference this, then x is the opposite side and we have the hypotenuse. So opposite and the hypotenuse, we could use the sine function. So sine 43 is equal to the opposite length x divided by the hypotenuse. If you multiply both sides by 1,000, then x is simply 1,000 times this sine 43 degrees. And that's approximately 682 feet. Now, if we want to find y, use a similar method, but this time I've got the adjacent length that I'm searching for, and I can use the hypotenuse, 1,000. So adjacent to the hypotenuse would be cosine function. So we could say cosine 43 is equal to y, the adjacent length divided by the hypotenuse. So y is equal to 1,000 times the cosine of 43, which is roughly 731 feet. Question 5, finding the exact value of 2 pi over 3. This could be a unit circle, something that we find on the unit circle. So 2 pi over 3 is 120 degrees. It's in the second quadrant, so we know this should be cosine is negative. The definition of cosine on the unit circle is the x value of the point there, which is negative 1/2. For negative 3 pi over 4, when we're going to use the unit circle and you have a negative angle measure, you measure counter or clockwise around the unit circle. So 3 pi over 4 measured in the clockwise direction lands at actually 5 pi over 4 or 225 degrees, which was in quadrant 3. So the definition of cosecant on the unit circle is 1 over the y value at that angle measure. So at 5 pi over 4 or 220 degrees, it's 1 divided by the y value, which is negative root 2 over 2. So simplify that and we have negative 2 over root 2. Question 7. The definition of the secant of any angle theta, and this was from section 1.6, is r divided by x, or if we want to use right triangle terminology, we have the length of the hypotenuse over the adjacent length. So we need to find the opposite length. So if secant is r over x, what we need to find is y. So we have x squared plus y squared equals r squared. This is 576. Subtract on both sides, we have y squared equals 49. Now the square root of 49 is plus or minus 7. But if we're in quadrant 3, both the x value and the y value of a point in quadrant 3 is negative. So the y value will be negative 7. So now the value of the remaining trig functions, sine theta is y divided by r. So y is negative 7, r is 25. Cosine theta is x divided by r. X is negative 24. R is 25. Tangent is y divided by x. So negative 7 divided by negative 24, positive 7 24ths. And then the cosecant is the reciprocal of the sine function, so it's negative 25 sevenths. We already had the secant, but I'll write it anyways. The secant is negative 25 fourths, 25 24ths rather. And cotangent is the reciprocal of tangent, which is 24 sevenths. Question 8, we need to find an angle theta, and what was proposed in class is we use the unit circle for this. And at this point in time, that's the best way to solve a trigonometric equation. We'll learn a more precise way, or a more general way rather, in Unit 2. But for right now, we can use the unit circle. The definition on the unit circle for cosine is x. So we need to find points around the unit circle whose x value of that point is negative 1/2. And that occurs in two different places. One of them is in quadrant 2, which makes sense because cosine is negative in quadrant 2. So in quadrant 2, the value is 2 pi over 3. And remember, to allow for all of the different coterminal angles of 2 pi over 3, we add 2 pi k. The other place around the unit circle where there's a negative x value of 1/2 is at 4 pi thirds. And again, we're going to add 2 pi k. Now, number 9, verifying an identity. I'm going to choose to work with the right side. To me, that seems like the more complicated side. So tangent theta times secant squared minus tangent. So I notice this term has tangent as one of its factors, and this term has tangent as one of its factors. That's a common factor. So I'm going to factor out tangent theta, and that's going to leave secant squared theta minus 1. And then secant squared theta minus 1 is one of those variations of the Pythagorean identity. So secant squared theta minus 1 is tangent squared. And if you multiply tangent times tangent squared, we're going to get tangent cubed of theta, which is equal to the left side. Okay, question 10. We have an x value and a y value. The definition of the trigonometric functions of any value of any angle, not just the special values around the unit circle. This was from section 1.6, is that sine is y over r, cosine is x over r, tangent is y over x. And then we have the reciprocals of all of those for cosecant, secant, and cotangent. So if we have x and y, what we need to find is the value of r, and that's equal to x squared, the square root of x squared plus y squared. And the square root of 106 is not going to simplify. So we're going to leave that as a square root of 106. So we can find the value now of all 6 trigonometric functions. For sine, it's y divided by r. So this is negative 9 divided by r. For cosine, it's x divided by r. It's 5 divided by root 106. And if we notice here, the sine is negative, the cosine is positive. If we consider the location of the point, 5 comma negative 9, that's in quadrant 4. If you recall, in quadrant 4, cosine is positive and secant will be positive. So cosine and secant will be positive. Every other trig function in quadrant 4 should be negative. So sine should be negative. Tangent should be negative. Definition of tangent is y divided by x. Cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangent.